In this class, this is the first video, we will start with the chapter number 1, ceramic fabrication process. First of all, ceramics. Ceramics covers a wide range of materials. Broadly, it is divided into two parts, traditional ceramics and advanced ceramics. Traditional ceramics bear a close relationship to those materials that have been developed since the earliest civilization. They are pottery, structural clay products, and clay-based refractories. We may also include cements and concretes and glasses into traditional ceramics. The other one is the advanced ceramics. It was developed within the last 50 years. It includes functional ceramics that have electrical, magnetic, electronic, and optical applications, while the other one is the structural ceramics that are developed for certain structural applications at elevated temperatures. Now, this figure gives an important relationship in ceramic fabrication. First of all, the chemical composition. The chemical composition depends on the selection of starting materials. Purity of the materials are highly important in the selection of the composition. Structurally, if we talk about materials, they are either crystalline or amorphous. At atomic scale, the structure of material refers to the type of bondings and the crystal structure, whether the material is crystalline or amorphous. But at a larger scale, the structure of a material refers to the microstructure, which tells us about the nature, quantity, and the distribution of the structural elements or the phases present in the ceramics. Microstructure tells us also about the crystals, glasses, and even the porosity. The other thing which is very important is the properties. Properties of a ceramic play an important role in determining the application of fabricated ceramics. It is important to distinguish between the intrinsic properties of a material and the properties which are dependent on microstructure. As properties of a material is a combination of both these properties. First, intrinsic properties. The intrinsic properties are determined by the structure at the atomic scale. These properties are not subjected to change significantly by modification of microstructure. It includes melting point, elastic modulus, coefficient of thermal expansion, and whether the material is brittle, magnetic, ferroelectric, or semiconductor are all intrinsic properties. While the microstructure related properties includes its electrical properties, dielectric constant, its strength, these are all properties dependent on the microstructure. Now, ceramics, there are a number of methods, fabrication methods through which we can fabricate ceramics. Broadly, we divide the ceramic fabrication process on the basis of starting materials into three groups: the gaseous phases, the liquid phases, or the solid phase. Here the table shows some of the methods classified on the basis of the starting materials. Here you can see few have more than one starting material. First is the gaseous phase. By the gaseous phase, the method for fabrication is chemical vapor deposition. For gas-liquid phase is the directed metal oxidation method. For gas-solid starting material and liquid-solid starting material, both have a reaction bonding method. And for the liquid, we have sol gel process and the polymer pyrolysis process.